Okay, welcome back everyone. We waited a couple of minutes so that everybody is there. Today's lecture is a practical lecture. And before I further talk, just a short feedback, please, if you can hear me.
Yes, I can hear you.
Okay, thanks. So the aim of this lecture is really not to be, coming out of this with a real Python expertise or Jupyter expertise. It's much more giving you some initial ideas what Python is, what programming with Python looks like, and how the Jupyter tool set essentially makes it much more easier to enable really cloud computing remotely. But before I talk more about Python and Jupyter, let us go back to the last lecture. If you remember in the prologue, we had a little bit about the course motivation, and the idea was, of course, to give you some information what the course is about, what motivates this course, and what challenges you basically can overcome if you have the, let's say, tool set, mindset, and skill set of the course material. The first things which is really notable is that machine learning, data mining, and working with small data sets in the past was always very easy. And there are lots of tools out there, MATLAB, Weka, scikit-learn, that can actually do this. And they do this until today very brilliantly. There are machine learning algorithms, data mining algorithms that can do this, support vector machines. That's all quite nice. And in general, you would say that traditional learning models don't require large data sets. So they're very well equipped, and we still in our research group, for example, use support vector machines with relatively low number of data, and they have very good accuracy. And these are the data sets where really large deep learning networks have trouble with. So if you go to small data, which is important to understand, then deep learning and all what you hear in the media has significant challenges. There are workarounds that work. Data augmentation are some of those which can turn a small data set into a larger data set. Things like image rotations, pixel in, pixel out, things like this. But in general, you would say the larger the data, the better for deep learning, and the better the accuracy really. And of course, then also the powerful algorithms you can employ. So this is in the end one axis, the big data, which is if you do this more and more with the examples today in this lecture in Python, we will have some data mining algorithm, for instance. He will not scale, right? So the algorithm will not scale to big data. It's a problem. We have to think about this, and we do this in one of the concurrent lectures. Another element that you would basically see together in this is the more you have this deep learning networks trained with more and more data, what you really require is more and more computing. And with this, I mean really the training time. So once a deep learning algorithm is trained already on big data, then that is what we call inference. It's really quick. So there's not necessarily that you need large computing. So essentially, when we talk about machine learning or data mining processing, that's where the large footprint comes in, where you require cloud computing resources or even high performance computing resources. There's a slight difference that we also will see and understand in lecture 1. So in the end, what this course is then really about is think big, think scalable, what you see on the bottom left. Don't think about one item, think about what you want to do with 1 million or 2 million items. Which was essentially then also leading to the 3 ingredients why there's so big breakthroughs in machine learning, in parallel and scalable data mining today. We said big data is there, it's real. Large data sets, they can be actually also kept because basically the cost for storage is relatively low if you compare many years ago. Then the hardware advanced significantly. We have graphical processing units, GPUs, which are basically a general processing units today, not just used for games. And we have more and more HPC and parallel systems available. In the past, this was a very specific system for just really cutting edge researchers. But today we see that many, many people have access to HPC and parallel systems. Of course, also because in cloud computing, you can have easy access today. And then the third item which really made a big difference is a software. And we see that today again. We will use Keras, we will use Jupyter, we will use Python, everything open source. No hidden tool set, nothing which is a black box. So there is lots of software around. Parts of the logos you see on the right-hand side, right? Spark, open source, Hadoop, open source. Lots of things which can be deployed in very popular cloud environments like the Amazon Web Services, Microsoft Azure, Google Cloud, but also in your own clouds. Or as I will talk throughout the lectures then, every now and then also in academic clouds, which are there for researchers like the EOS, the European Open Science Grid. So with this, I heartily welcome you again to this course and hope you find the course very useful. I'm very open-minded also to feedback. In the past, this course was grown based on feedback. So this means the lectures and their, let's say, outline when we put which assignments. So all of this is also based on student feedback over the years. So please be welcome to send me any feedback. And I also should invite you to the discussion section. So when we had the briefing of how to use Canvas, how to engage with students, we got also informed that it's a really good way to perform the discussions, to get you more, let's say, behind the scene knowledge, to discuss the material with your fellow students. So you see that basically I would have for every lecture something like top 3 discussion items. Please use them. They're there for you to really get the material in your heart. So much for the last lecture. Today we have really an additional practical lecture, which is in some form a little bit optional. So all of those of you who have, programmed Python before will see simple loops and variables, very boring for you. And all of you that are very familiar with Jupyter, Jupyter Labs, and so on have used that a lot. This is of course also another key ingredient of the course, but also here of this lecture. So this is just, for those people which are never used Python before, perhaps never had access to Jupyter or Jupyter Lab before. And of course, applications is a very important thing in this course as well. As you see, every now and then we have practical topics. Today you will learn how to analyze retail data, shopping lists, for instance, which is a very practical concern as a starter in machine learning. We have some retail projects where we analyze shopping data. So if you buy this product A, we can know for certain that you will also buy product B. And you will see how remarkable easy that is today to really do this. But before we come there, let's some basic foundations about Python. So I will talk a little bit in the beginning, so to have a concrete foundation to stand on. And then we will explore what really are important libraries for Python. We will see that deep learning libraries actually also on top of Python have made deep learning extremely popular. We see that the environment, how to access large computing resources today is not as complicated as it was 10 years ago with large SSH keys that have to be created. It's still like this in here and there environments. So interactive supercomputing, interactive cloud computing is still relatively new. But this is possible, and the Jupyter, or Project Jupyter, if you will, was really an important ingredient in all of this, and we will explore that, especially also when we do the demonstrations of the course. Then I would like to take the opportunity today also to invite you to 2 certain different ways of thinking. You always would be, as a data analyst, or a guy having still your local laptop, analyzing data. And you could use this, for instance, with the Anaconda distribution. It has Python, it has Numpy, it has Pandas, it all kind of different frameworks. You need to do this locally on your laptop. But as soon as you approach big data, hence the topic of the course, you will see that actually 2 gigabytes just in memory for retail data might be a big problem. So I need to go to some cloud computing center, to a supercomputing center to obtain HPC resources. And so you will use Jupyter remotely, but you can also use it locally. The benefit of this is that if you have a Jupyter notebook, you can download it and upload it again usually on the cloud computing resource. So your work that maybe was working with small data can still work with large data. Of course, then the systems in the cloud usually have either more memory, more computing capacities. In deep learning, you will learn how to interconnect GPUs to have much more GPUs than one for performing deep learning training. So all sorts of things which your local laptop can never achieve. And these are the things where it's extremely easy today to really port your applications for data science to the parallel environments. The second part then of our lecture or course hours today will be really thinking about some demonstrations, and of course take away the message that I cannot give a complete introduction to Python. That would require a complete course. So we go through some basic variables, simple loops, and so on, and have some, let's say, hidden treasures in vectors, matrices, and arrays, because they're usually used for machine learning a lot these days. And there's some, let's say, hidden treasures with errors, which you can do, not differentiating them. So in a way, this is really to show you a bit more focused where Python is important, how you could use Python. And of course, if you want to be in Python experts, I really have to recommend you to take a proper Python course. That's not what this course is about. However, we will use Python for the assignments. And as I told you already in the prologue, these are not really big programming assignments. Also, programming is an aspect which is not directly the focus of the course. You can use basically Matthias Bog's lectures in software engineering, programming, and other of my colleagues that are teaching programming basics. Here, the idea is rather how we can do Python in cloud computing and using it for something useful. And something useful these days with big data and in cloud computing is by large, basically everything which is related to machine learning, data mining, sometimes referred to big data analytics. And it's not clear and obvious what that means to you, but it will materialize when we have the lecture by lecture where we talk about these things. And in order to not give you a very cold Python demonstration with, going the API down and up, I provided you here today with two small applications, which are also we will, throughout the lecture, come back to also revisit then the big data problems in them, how we can really learn from these data and things like that. So this is really a practical part in elements, which you often use in trainings, but also one of my PhDs here, Shadi, who is maybe on the call, he is using really data mining applications with perfume data with the algorithms we provide here. So it's really a practical substance. And of course, you have to learn then how far you can go with your data until you reach maybe to big data problems. So often you start on a local laptop and then end up maybe in the cloud or at the supercomputer, realizing you get much more data than you previously thought of. Now let us start a little bit with Python environments, and to come back to and connect actually to the Prologue lecture that we had in the beginning. Think again, we said if you do, for instance, machine learning with big data or data science as it is called today, you would have a feeling that there is a pattern, but there's no mathematical formula. So in a way, you have to search for this mathematical formula or to create it with machine learning algorithms in a way. Some call it maybe function approximation, like in mathematical terms or statistics terms. It's not exactly that, it's different. We will learn this in one of the machine learning fundamentals, what the difference is. But if you would have a mathematical formula, like for instance, they do in the physical areas, physics for weather, for instance, is relatively good understood, then you would rather implement this formula. So meaning machine learning is usually about data, and these days learning from big data is really a big thing. And as you see, it's not really something for machine learning alone, it's data mining, applied statistics. And really there's lots of research right now and actually lots of solutions in clouds today of handling big data. So the chances are if you come to your company outside in the field, you really have really working solutions in things like Amazon Web Services, Microsoft Azure that we will all review during the course. Here we start low. We say, okay, the common thing we have right now is we don't know anything about cloud computing yet, really. We don't know anything about HPC yet. So let's start simple. What is a simple thing? Python is simple, it's nice, it's easy. We have Jupyter as a very nice project which is actually not only for Python. You can use Jupyter with C, with R, with different frameworks, with different programming languages. And this is a beautiful thing. So in a way, this is really just one ingredient. We will then, of course, look in lecture 1 next week what it really means to cloud compute, what means high performance computing. This would be too much here in the lecture. That's why we'd rather start with something what perhaps some of you already know, or what is, let's say, very easy to understand. When you look at the Python programming language, it's open, everywhere available almost. And basically, there's lots of good support in terms of how you really program. We will see this when I do some demonstrations later. So you would have here on the right-hand side, a very good script shows you how you nicely can combine, for instance, a string with real calculations. You have a very way of interpretation. You don't really compile like in a C program, a very big executable, then basically you have to execute this executable. So here you have really an interesting quick language. And you would say that really in every cloud computing environment you go today, almost everyone, there could be always one which not supports it, but chances are there is definitively Python. And the interesting thing around Python is not Python alone. It has lots of libraries, packages, what you can install with a so-called tool pip. And I give you basically an example for Keras on this, where you can nicely install packages. And one of the most used packages is Numpy, for instance, more popular these days, getting also Pandas. And I will talk briefly about it. But this is really a tool, if you have the chance now, I would say go back 10 years, you would maybe say R is still important as a data scientist. Today you have Python to learn. You have to know about scikit-learn, a serial package for machine learning, Dask. There are different workflow languages that puts on top of it some parallelization. But in the end, Python is really what you have to learn. And that's why I encourage you also to think about it. Now, when we talk about Python now as programming language, we have to think about one important difference here, which is essentially the way how you use now programming. And this is something which is often not completely understood. That's why I brought it in. You have to think about that classical programming, as you know, and machine learning programming is a bit different. So you see this nicely on the picture on the basically below here, where you have classical programming, where you have some program you want to do, you take some programming language and you have some rules what the software should do, and you would give in some data. And of course, then there should be done something with the programming. You have a precise way of a source code tree that goes through if, then else, and for loops, and anytime then call some functions, procedures, and it gives you the answers, right? It calculates something from the data. A very, let's say, very hard-coded source code. Of course, when you now look into machine learning, it's a little bit different. We have already those answers. Now, basically, if you see, we have also data. Let's have a movie recommender, for instance. We know, basically, you look these and these movies. You like them very much. So this is basically the answers we have already, the liking, right? So, and now basically we have the data around all the movies. So is it comedy? Is it action? Is it a Western? And what we find out is rules. So could we get something out of your personality to think about what are the rules, why you like Western so much, why you like action movies so much? Is there some feature in the personality, or is there some, let's say, rule we will find basically in the movies that they're exceptionally good, right? So this is a different way of programming. You still have some machine learning source code, which would be a very, let's say, interesting Python code maybe, but it will be not really with very large source code structures with many functions, many procedures. You still would have a couple of functions and procedures, but it's really, let's say, much more streamlined because the focus will be more on the data, on pre-processing data and how we can encode features, things we already know in the answers to encode in the machine learning algorithms. So I think this is an important distinction, of course, for you. Some of you, it's really maybe still the first time touching machine learning, and you will see during the course how that materializes, that this is a little bit different than traditional programming you maybe know from Java programming or from other scripting languages maybe. So when I think about important Python libraries, I don't want to talk too much about it. I think many of you have heard maybe from Numpy already, especially some of you that are already doing some scientific work maybe. In other courses, this can be nicely used, for instance, for using really arrays in all sorts of ways, n-dimensional arrays, matrices, everything on vectors. So long story short, that is really a very nice tool when you want to work with vectors and these things. And it has just a couple of course source code lines, right, to really give a very quick vector out. You see here an example that we later will touch on. You see it comes with a random number generator, that is also handy. This also gives me the importance to say that these packages are not always directly in Python. So we have this import those packages with a certain statement that you see here on the slide, import numpy as np. While numpy is relatively fixed, this np can you vary. You can, have your own name for it, but let's say there are sometimes conventions for the readability. And by far the most machine learning code I have seen is using NP for it. But that's where you are free. And then you see how nicely you can create a vector. And later on in our application examples, we will see how we can use it for data pre-processing and so forth. And on the bottom here, you see all the different areas where this makes sense to use and where it's actually indirectly or directly used. From quantum computing over statistical computing, signal processing, mathematics, even in simulation tools, everywhere are these tools. And it's really a nice helper tool. Of course, in the end, it doesn't do really magic. You have to program what you want with it. Like here we create a vector which has some 3 random numbers, but this is something what we will see later when we have some real application examples. Similar is Pandas. So if you have Pandas, it's by far now, I guess, the modus operandi if you want for having data structures and to work with data structures. And you see essentially on the right-hand side, it works even very nicely together with NumPy. If you have here an array that you want to find, so to speak, in a more formal data frame, which is kind of de facto or the primary data structure really of Pandas. That's why I put it here so bluntly. Don't think about that Pandas is just a data frame. You can do hell a lot of other things with it. Here's one example, which is very nice to easily read just data from files. And also here on the bottom, you see it's really used by a lot. It has lots of sponsors and is very popular these days, not only in our ULI supercomputing center, also you see it in cloud computing environments to become more and more popular. And when speaking of popular, you can see already in the media in the last 5 years that packages like TensorFlow and Keras, they are now really often used for deep learning. Deep learning will be several lectures where we'll talk really in depth about what deep learning algorithms are. I will shot a little bit on it when I go to lecture 1, but really think about that this is of course a more or less introduction that Python is also useful here and has enabled a lot because this coding is so quick with Python and TensorFlow packages and Keras packages, which kind of sits on top of TensorFlow as one of a higher level library for TensorFlow if you want and for deep learning. This has really enabled a lot. And underneath, really, in TensorFlow itself, you will see it can execute on multi-core CPUs and many core GPUs, which we have in the cloud or on HPC machines. So you see its scalability by design. You have a small Python code, but inherently in the package, you have already the scalability to really go for big data if you want to. And we will explore this, of course, more in depth when we have lecture 6 and lecture 7. And this brings us a little bit to revisiting the deep learning techniques. And one of the things we will start a little bit today when we think about the pre-processing of this digit recognition that we had the last time. So we will think about that, okay, what we have to do with Python to load such data, how we can visualize the data and how it's encoded. And this will be demonstrations I perform later. The deep learning part of it will be then coming in subsequent lectures. But here you see already that basically pre-processing is necessary and Python is just an excellent tool to really do this. So here we connect directly to our Prologue lecture. Some of you always asked me in the beginning when we had this course and students essentially were saying, what is a tensor, right? So people know usually about vectors. people know about matrices. They also know about arrays, but what the hell is a tensor? And you know, TensorFlow says it all. These are the things which are flowing through a deep learning network. That's why the name tensor became so obvious. But in the end, you can see it just like a multidimensional array, right? So there's no magic about this. It's just that the name tensor is more general. You would say a three-dimensional tensor or a two-dimensional tensor is nothing else than a matrix. Because you use more dimension right now in deep learning, actually you can use 3D. That was previously not possible, let's say, in artificial neural networks, where you have to normally just vectorize everything. So this is an important name just for the sake of clarification. Now, when we think about starting some demonstrations, the first demo I want to give is local here on my laptop with the Anaconda distribution. And this is something you can freely download. And if you want, I really recommend this in the course. It's not directly needed for the assignments because we usually go more for cloud computing resources and we'll do there something. But if you want to play around with Python, if you want to get familiar with Jupyter, you can start downloading Anaconda here on the web page. It's free. Make sure you use basically the free edition. There's also an enterprise edition, but it has a remarkable set of libraries. You see that here on the right-hand side. It has Jupyter, of course, and Jupyter Lab as the IDEs. It has Numpy and, of course, all the different workflows like Dask for machine learning that you maybe want to use. And of course, also machine learning packages like scikit-learn, but also TensorFlow is there. Of course, in the end, machine learning in terms of deep learning will be very restricted on your local laptop. That's clear. You don't have a large computing capacity, maybe one GPU, but that's it. Still, it's useful to download it if you really want to, you know, play around a little bit with the substance of the course. For instance, the MNIST that we will do here today, start a little bit and also having throughout the course as an example is a very lightweight solution that you can always run on your laptop. So it's really coming then to the question, what is this Jupyter tool I'm always talking about? And this Jupyter tool is best explained when we have a demo now, and I think I will do this very quickly now. But it's an interactive data analysis using clouds, and you will see and get it really by heart when I will do some demo here. You see also it's really deployed in many clouds and high performance computing centers today. It has so-called notebooks, which could be not only Python, it could be a C notebook, it could be an R notebook. Often it is used with Python, but of course, not always. And it has very nice visualizations you can do while coding, right? And you really can have explanatory texts, formulas. It's beautiful, and you just have to use it to really understand it. And in order to understand maybe also the difference between local laptops and remote cloud system and HPCs, we start a little bit with a demonstration here on my local network. On my local network, of course, means I have it here on my local laptop. You can also have it on your local server, but it's not really remote in the cloud, right? This is basically just an IDE in a browser. So you see here, localhost refers to the fact that this is on my local machine. And you notice also it's just Jupyter here that I will use for the demonstration. You see I already installed here Anaconda before, and with this, when you install it locally, you will see you have access to Jupyter. And when it runs, you see direct here localhost, it will start. And again, this will be just running locally on your system. You would have a lot of, you know, directories, a relatively simple view because it's just Jupyter and not Jupyter Lab. But Jupyter is still good enough to go through several things. We see here, for instance, a short info when I say a little bit about basic examples later. When you say you have here the usual start script, now executing this Python code and you have the output directly at it. Admittedly, this is very, very simple, but still, if you think about that, you have a string to be combined with a real value computed, it's quite nice and streamlined. The way how you have loops is very streamlined. You see that here. We can have languages, German, Spanish, Italian, and so on. There's a simple for construct, so also loops are possible, and you can print them. And of course, another basic thing in programming languages are if statements. That means essentially, if you're German, Spanish, and only in the Icelandic loop part, we want to say welcome to the University of Iceland and then break, which essentially means with a break we go out of the loop and never reach Italians. So all Italians today here, sorry for this, but all of you again, welcome to the University of Iceland in my local Jupyter. I think you get a little bit the meaning. It's of course very simple, and you can now go back to the hierarchy here. You have a kind of folder hierarchy of running those in a different tab. You will see also when we come later to examples from association rule mining, there's already some Python notebooks which are more elaborate, and we will talk about it in the second part of the lecture. But this is really fine and nice to be used. Good, so before taking away too much material from the second part of the lecture, let me come back and think about, before we close with the first part, what it now means to go remotely, right? And this would be a system we're going to use in the course a little bit. Of course, we also use real cloud providers, but they of course cost money, so we cannot use them infinitely. That's why we also use for some of the aspects also our system at the Jülich Supercomputing Center. And you see here directly from the link that we're using here Jupyter -JC at FZ Jülich. And with this, we have a remote system we're going to use. And the added value also of this is what you will see is that it's a Jupyter Lab. It's the next generation of notebooks having also a tab, basically some space on the left side to share data. You have a Jupyter Hub, which means it is a multi-user environment. And we have here a paper if you want to know more about this. It just means that essentially Jupyter is traditionally rather for one user. So Jupyter Hub connects it with things like LDAP, with a database of users, using Unicore and identity management to really connect to multiple users at the same time, right? And this is an important aspect, of course, of a cloud center. Or if you want to have, for instance, a class, as you see here on the right-hand side, which is one of our last training we gave in the Supercomputing Center for PAAS users. It's a large HPC infrastructure. There we had maybe around 30 participants at the same time using Jupyter, using the Jupyter Hub functionality to access the supercomputers and the cloud resources we have. So you also can have, of course, a link here seen. There you find also more material, other Jupyter notebooks and so forth. So let's go, before we close the first part of the lecture here, really to understand that this is now locally running here. I have localhost. If I now want to use Jupyter at JSC, I have to go a different way. I go to this web page. It gives you already some nice information about what the Jülich Supercomputing is offering in terms of the Jupyter functionality. I will give you in one of the assignments a way of how to register to this, and then you can log in having your UDOR account. And the UDOR account we will basically explore together as first part of the assignment. And you see that here in the HDF cloud at the Jülich Supercomputing Center, I have already a TensorFlow notebook running, and I can just start this. So you see, basically it's not running on my laptop anymore. We have a cloud resource which has nothing to do with my laptop anymore. The only thing I use locally is my browser, right? The browser is of course locally, but we connect with it using HTTPS essentially to the Jupyter at FZ Jülich. And then you basically have here the data and all the things you usually would have in those projects. It depends always. We will show later an example, what you basically share with your different colleagues, with your research groups, with your analysts. You have here the possibility to have Python again as a language, but as I said, there could be also other kernels that you can implement and can use. And with this, you basically then have a full flexibility inside the cloud. There are links to things like Git and lots of different things, we will explore also during the part of the second lecture. So again, important is now that I have here another Jupyter running. It's localhost. That's the one on my laptop. And I have another basically running, which is then really in the cloud. And this will be a key differentiator, of course, then in the lecture. That's why I drew some basically emphasis on it. And of course, import Numpy as NP. You see you execute it the same way with Shift Enter, but something what we also explore in the second part of this course. So basically that's it for the first part. Let us just review some small aspect of it. This is really thinking about that you have to have an account for the Jupyter JSC. So wait before I give out the assignment. So then basically it says everything, how you enroll in this, how you get access to this to play around. But if you want to start before, you can always use the Anaconda distribution, right? You can download that already now and then play around with Python and Jupyter and Numpy and things like that. Good, so much for the first part of the demonstrations. We stop here for 10 minutes and then come back after the break for the next part of the course.